This week's topic is Advanced SQL. This is a continuation, obviously, of what work we've done with more basic SQL. There isn't a huge amount of content here. We're going to talk about distinct and aggregates. We're going to talk about grouping with having, and we're going to touch on also insert, update, delete, just to kind of reiterate those because we've talked a lot about queries. I just want to come back and talk a little bit about that. We discussed it a little bit when we talked about creating a database, but it's worth revisiting. And another important topic is going to be transactions, because database management systems today, relational database management systems today, commonly are not doing one query in a vacuum. You have to say you're doing a bank transaction. If I'm paying you money, the bank has to make sure that they first debit my account. Maybe they check for funds first and they debit my account, and then they have to credit your account, and then they have to verify. And if something went wrong in that process, say after they debit my account, they have to be able to roll it back, because they can't just have it fail and then have me out the money and you didn't get the money. The money just poof, went off into the ether. That's no good. Similarly, when you register for courses, there's a bunch of things that might happen there, right? You might register for the class. It has to check to make sure that there's seats in the class, and it has to insert you into the class, possibly update some kind of historical record. Maybe it also has to update your academic record in some way, or check to see if you're ready to graduate, or some other piece, right? So all of these things that get lumped together are considered a transaction, and we'll take a much deeper dive into that as we go through the topics here. The first one is very simple. This one is a way that we can, say, whittle down our results instead of getting all the results in a certain attribute. Say we just want the unique results for a certain attribute. So, if we had a simple table with some first names in it, let's say you had 2 Brians, 3 Sallys, and 6 Amandas or something like that. If you use select distinct first name, you would get just one row for each unique name. So in that case, you'd get 3 back. You'd get Brian, Amanda, and Sally. If I leave the distinct off and I just said select first name from user, then I'd get back, all the rows that I said, whatever it was 2 Brians and 6 Amandas and whatever it was, right? So distinct is just that. Whatever attribute you give it, it's going to return to you just the unique values within that attribute. So if you had an attribute for, say, city, and you want to find out, how many unique cities do all the records in my database live in? Like maybe you're a college and you want to know, how many cities do my students come from? A distinct is a great way to do that, right? So a wonderful way to return a unique set of values for a particular attribute. Aggregation is now a way that we can add kind of functions to our attributes. So if I want to say know the average price or the min price, the max price, if I want a count of all the records that meet a certain criteria, or all of the records in general, I can use these methods to do that. So in this example, I have an imaginary table called product that we have to infer here holds cars as the product, or at least partly does. And I'm selecting here the attribute price, and I'm wrapping it in an average function. And what I'm going to get back here is basically it's not going to return to me all the tuples that have the maker equals Toyota. It's going to look at all the tuples where the maker equals Toyota, get the price, and then average it for all of them. So if there was 10 rows there, it would take those 10 rows, it would add them up, it would divide them by 10, and it would give me back that average. Now, it's important to note that obviously, because we had that where clause, that we're limiting it by Toyota, but if you took that out, it would give us the average of all products in the table. This would manifest like if this was a real thing, it would, take your Corolla, or I don't even know what the smaller Toyota is anymore. It would take that price on the low end, and it would take whatever the highest price Toyota is, like a Land Cruiser or something, or an Avalon, and it would take all those prices and average them out, and that's what we get. And if we took the Toyota out, we get the average price of all cars, right? Assuming that it was only cars in the table and not other types of products, but just going on the fact that maybe that would only be cars. Another example, this is count, right? So count is a way to count the tuples. If I just say count star in product, if product has 10,000 rows in it, I'm going to receive back 10,000 as the answer here. Now notice here we also have a where clause where the year is greater than 1995. So maybe out of that 10,000 where the year was greater than 1995, I only had 3,000, right? So if that's the case, then this would return 3,000 because I have that where clause. If I remove the where clause, it would go back to 10,000, right? So count is a way to count something. You don't have to do count star. You can count a particular attribute too. In fact, I have an example here that I think does a kind of good way of laying out the difference. So if we look here, if we imagine that we have our table product and we want to count from category, if we write it this way, just count category in product, it's quite literally going to count as if you would put count star. We haven't limited it other than the where clause where it says year greater than 1995. We haven't limited it anyway. So I think what's implied here is that you would think if I say count category, I'm going to get like unique categories, but that's not actually the case. So a better solution is what we have down below, right? Count distinct category from product where year is greater than 1995. Now, if you have those 10,000 rows or whatever it was from the last example that we were talking about, let's say there's only like 6 distinct categories in there. The second query will actually return that. It'll return 6. But the first one will return 10,000, assuming that there's no nulls in category. So that's a big difference, right? So I think when you see something like the first one, you're thinking it's going to respond like the second, but that's not actually the case. So this is a good way to combine distinct and an aggregate function to achieve the results that you're looking for. We can kind of expand this too. So you can do a lot more with this. Let's imagine that you want to actually find out what like your sales are just based on, like say a purchase table, without having an application behind it to provide the business logic to do all this stuff. So one way to do that would be something like this. Just select price times quantity from purchase. What's going to happen there is for each and every row in your purchase table, it's going to multiply the price times the quantity. So if I bought 5 things at $10, that's going to give me a result of $50, right? And then if you bought 10 things at $10, it's going to give you a result of $100 for your row. And then it's going to sum up our rows. So if we were the only 2 rows, the sum of that would be $150. And we'd know what our sales were for, whatever was in our where clause, which here there isn't anything, so it would be for all of our rows. Another example down below then says, okay, well, what if I want to limit it? So I'm going to throw into it a where clause where the product equals bagel. So same thing, sum price times quantity, except now we're looking specifically at the product attribute and we're saying we only care about the ones that were bagels. If you bought a donut, I don't care, right? So we can combine something like this with the where clause to limit it further. Now, there's a whole nother way to do this, though, that I kind of want to dive a little bit deeper into. So grouping works interesting with this, and grouping is one of those things that it's a little finicky at first when you first try it, but once you get used to it and you kind of get used to the duality of how you have to pair the group with the aggregate, you'll see that it makes a lot more sense. At first, you might get a lot of errors if you try to select other attributes that have nothing to do with the grouping or the aggregate, and it might be confusing, but I think once you see how this unfolds, those errors will at least make sense and you'll know how to fix them. So basically what's happening here is we're going to try to find the total sales of something after a certain date, so October 1st in this case, buy a product, right? So we're going to start by saying, select the product, which is going to give us the name. So, if it was like, the Avalon or the cars, or if it was the bagel or whatever. And then we're going to get the sum of the price times the quantity to get, how much the order was. And we're going to call that total sales. So we're just using an as here to give that sum a name. And then we're going to retrieve this from the purchase table where the date is greater than October 1st. And here's where the magic comes in. This is where we use the group by. So when we group by product, what we're saying here is that basically for each distinct product in this table, in the purchase table, like so say for bagels, instead of looking at all of our individual purchases and then summing those up, we're instead going to look at our individual purchases and sum them up, but by product. So we're going to say, maybe I bought bagels and maybe I also bought donuts, and we're going to separate those two things out. And the portion of my purchase that went towards donuts will be summed into the donuts, and the portions of my purchase that went into the bagels will be summed into the bagels. So what you'll end up with is a result set that groups that aggregate by the group by. So you'll see bagels and your totals, and donuts and your totals. And that's basically what we're going to end up with here. So we're going to have one tuple for every group, and we're going to apply that aggregation to the group. And that's key, because if you try to add other attributes that have nothing to do with either being the aggregate or the group, then it throws errors because the query can't deal with that. So the select can only have the grouped attributes or the aggregates. That's very, very important when you're working with grouping. Now, let me just show you too, there's another way that you can there's a few ways you can play around with this. The top one is a good example. It's basically the same one that we just looked at, right? We have the product and the which is the group by, and we have the aggregate. And now down in the bottom though, this is kind of a different way that we could do the same thing, right? We could kind of achieve the same idea with a subselect here. And that's okay. You could try it that way too. It's just kind of show that there's more than one way to affect the problem here. Now, there's also the having clause. So having is almost like a where clause for group by. So the reason why is because you can't apply it the same way. When you're using where, it's basically going to apply across like all attributes. But when you're doing group by, you're grouping them by a certain product. So if you want to limit something about that grouping, you have to do it in the having. So in this example, we're doing the same thing we were doing before, except we only want to consider products that had at least 100 people buy them. So, if like donuts had 110 people, but bagels had 90, we don't want bagels to show up here. And we're not going to be able to filter that out effectively with the where clause. We're going to instead, for that piece, want to do it with the having clause, because we're talking about the group. We're talking about the resulting kind of grouped aggregate piece. We can filter the date in the where clause because that applies to all attributes, right? In this case, we have where the date is greater than September 1st. So that's in the where clause because all attributes we're going to look at have a date, and the grouping has no effect on that date, right? The date has an effect on whether we return it into our data, but it doesn't have an effect on the grouping. However, when we look at a aggregate like sum, that has an effect because we're grouping data together to achieve that sum on quantity, and therefore we have to put it into the having. So because we're looking at the total quantity that came back, I don't know why, I just noticed, by the way, the example has 30 down there, and up there it has 100. I apologize for that. It should be 100 at the bottom. So, to keep it consistent, or 30 up top, but those two things should have been the same. But if we were checking to see that we had at least 100 buyers, then we should have a halving of, the sum of quantity is greater than 100. So it basically contains conditions that we can put on aggregate. Okay, so modification of the database is pretty straightforward. I'm going to just kind of walk through the syntax for these three things. Most of you have honestly probably seen this at this point anyway, so this is more of a formality just to make sure that you're comfortable. An insertion is when we want to put something new in the database. A deletion is obviously when we want to take something out, and by something I'm talking about tuples here. And an update is when we want to change something in the database. Now, with the update, we're going to update a tuple, but we don't necessarily have to update the whole thing. We might just change certain attributes. So, that's kind of an important piece, is that it doesn't have to be a wholesale replacement. It might be a more strategic one. So the format for an insert is basically, and this is standard SQL. Again, there's some variances, but not so much with these basic statements, depending on the database management system. But the general form is insert into the relation, and then you list the set of attributes that you wish to put data into. Now, this is important because if you don't list all the attributes, if you say leave some out, like say you have a table that has first name, last name, and email address, and you insert into user, which is the table, say first name and email address, and then this next part you have values, and in the values you put, say, Brian and brian.gormanley@marist.edu. My last name in my row, assuming that it allows me to leave a null there, will be a null, right? So that's very important, that if you don't include the attribute name when you declare the insert into relation and then those parentheses and a value for it, then you'll end up with a null there, right? So I actually wrote that down there at the bottom with the missing attribute. Here's an example query. So insert into purchase. The attributes that we're going to be inserting data into are buyer, seller, product, and store. So there's 4 of them. The values are Joe, who's the buyer, Fred, who's the seller, the wake-up clock espresso machine is the product, and the store is the Sharper image. All right. So if, for example, I had left seller out or passed no value in, that would have been a null for that attribute when I did so. Again, if the table is set up to not allow nullable attribute, an attribute not to be nullable, then it would throw an error. It wouldn't let you insert into the table. This is another insert here. This is an example where we're inserting into product, and we're actually using a query to insert. So this is actually a very common thing, especially if you're moving you're moving data from one database to another. This might be something that you do, right? You connect to both databases and you insert into one the query from another. That's not something that's out of the ordinary at all. So keep that in mind. You can always kind of compound different types of queries together to achieve a result. So this is just kind of the tip of the iceberg of what might be possible there. To delete is pretty straightforward. Delete from the relation name, and it's very important that you have a where clause, because you don't want to just delete everything. So you have to be specific and say where something is true. Very commonly, if you're using an integer ID number, the most common one you're probably going to have here is like where ID equals 636, or whatever the ID number is of the row you want to delete. But maybe you do want to delete more broad. Maybe you just don't like Joe and you just want to delete all his purchases, right? Or maybe Joe is no longer your customer and you don't care about the historical value of his purchases. Whatever it is. Apparently Joe really didn't buy the Brooklyn Bridge. You just have to specify what are the conditions that it must do, just like you would do in a query, except that instead of returning the data, it's going to delete the data that matches, right? So One thing that's actually a good hint, by the way, is because this is just like a query, especially when you're new and you don't like deleting data from like a prod database. Just be really careful. Like, this is something that when you get into the real world, um, you know, it's going to honestly probably be pretty rare that you're deleting data out of a database. Once the system is correctly up and working, there really shouldn't be a whole lot of reasons why you would be manually deleting data. You'll probably do a lot of it in development, like as you fine tune things. And of course, things will come up in the real world where you will have to delete data, but you have to be super careful. So, one thing I suggest is before you ever write a delete statement, you can change this very quickly to a select, right? You change the delete right there to select and put a star in front of it so you see all the attributes and leave the rest the same. So select star from purchase where seller equals Joe and product equals Brooklyn Bridge. It's going to return to you the exact tuples that will be deleted when you remove that select star and replace it with delete, right? So just a little bit of real world advice when you're faced with actually deleting something from a database, take the extra step. Just look at the data and make absolutely sure that that's what you want to delete before you do it, right? So just a little trick there that you can use. Updates, again, this is a lot like an insert, but an update is taking an existing row and changing it, right? So I have to say what relation, so update product, and then the syntax is a little bit different. You are specific about the attribute and value right here in the set. So you have set attribute equals value, and you can have multiple attribute and values there. In this case, we're doing it where a product name is in another query. So we have a subselect here where we're selecting products from purchases within a date, where it actually add a date, where date equals October 25th, 1999. And for that day only, we're going to set the price to be half off. I guess that was a good day to go shopping wherever this was, right? So that's a good example there of an update. If you have any additional questions on those, I think most of you have seen them. Put a question up in the forum. I'll be happy to throw out more examples of those. So, transactions. So a transaction is the unit of work that we want a database to do. So instead of thinking about like the individual query, we want to think about the individual unit of work. So like I was mentioning before, like if you think about a bank transaction, right? That's a unit of work. Registering for class, that's a unit of work. All of these things probably have multiple database queries associated with them. And we need a way to know for sure, because this is all very important data, that everything is committed correctly and uniformly, and there's no violation of constraints or any other issues, right? So this transaction, and what if the system crashed halfway through, right? Like what if somebody just accidentally, like pulled the power cord, and all gone, right? So, and the computer was halfway through the transaction. Was it successful? Was it not? How do I know? So a transaction is a way that the database management system deals with that. And effectively, if the transaction is successful, then everything's good. And if not, it can do what's called a rollback. And it can basically roll the database back to the state it was before the transition ever happened. And at that point, you can then say retry the transaction and to go forward. This applies to selects, this applies to updates, inserts, and deletes, right? So all of the queries and the updates that we've been talking about. Now, there's four kind of tests that we have to pass in order for a transaction to be considered valid in the relational database management world. Now, technically, there are some variances on relational database management systems and how strictly they adhere to what we would refer to as the acid test. But I'm not going to get into that. That's out of scope. If you're curious, you can Google it, for your relational database management system and learn more. What I want to do is talk about the important parts, which is what ACID is and why it's important and what are these four things. So the first thing that we need to prove for a transaction to be correct and valid is that it has atomicity. So basically it all happened, right? That's everything that we were kind of saying, and in the broad sense, this is the most obvious one. When I talked about the bank transaction and I said, I have to know if you pull my money and give it to you, that both of those things happened. That's what we're talking about here, right? That every step of the process was followed, for it to be complete. The second one is consistency. Now, this is, some of these terms might feel a little bit overlapping. You might think, oh, well, the data isn't consistent if all the things don't happen. Well, that's true, but that's not actually what this is talking about. You can think about this more like constraints. So the data must be consistent once the transaction is occurred, but it also includes things like my balance can't be below zero, right? So whatever the constraints are on the data, they have to be adhered to as part of the process. If at some point in the process a constraint is going to be violated, then the process has to be rolled back, right? That's the important part here, is that we're looking to ensure data consistency for constraints. My balance did not go below zero when you debited the money from my account to credit it to another account. Another piece of this is isolation. So regardless of, they don't always do this sequentially, but regardless of whether or not the transaction actually in real time happens sequentially, and all other transactions wait, isn't relevant, but it must actually do the job as if it did do it in isolation. And what I mean by that is, so imagine you're the bank, right? And you're building your database for your bank. To the user and the application programmer, it must appear to that code as if the database has done one transaction at a time in sequence without overlap or any risk of what you would call like a dirty read or something like that, where data could be read in an inconsistent state for another transaction. So, and by the way, you check in the book too. It goes a little bit more into that, especially the dirty read part. But basically, the name of the game is, like, let's say there's multiple transactions that are going to take place that involve my account, right? I'm going to pay you money, but Maris is going to pay me because woohoo, it's payday, right? So whichever one of those transactions was going to happen first, let's say it's important that Maris pays me first because I won't have enough money to pay you, then the bank system has to treat these transactions with isolation. Maris must pay me first. That transaction must be completed before the next transaction even starts, so that when you check my balance, you see that I have the money to pay you, right? Or conversely, if I didn't, right? So that's important too. So that's what this means. Now, the reality is that acting in isolation has big performance impacts, right? Because if I have to wait for every single transaction to happen, in sequence, and I can't take advantage of multi-core processing and all these other things, then, that might be a problem, especially when you're dealing with something like a database that's heavily I/O laden, meaning it waits for writes to disk and reads from disk. And if you guys have taken organization architecture, especially with me, but I'm sure with anyone, you know that these things take an order of magnitude more time, or many orders of magnitude more time than common processing. So a database management system is heavily I/O laden, and all of these transactions involve some sort of I/O, and you're just losing out on a lot of time that you could be doing things if you're quite literally following everything in a very particular line. So the way that they get around this is many layers. There's locking, there's all kinds of things applied. But in a nutshell, what the database management system will do is it will run transactions, parallel that it thinks it can safely, that don't have any risk of messing with each other. And it keeps a record of all of it. So if it has to unwind it, it can. The last one is durability. So this basically just means that once we've committed and the transaction is in there, we know that it's permanent. It's on disk. It's not like we did all the steps and just as the last step was about to be written, all of it was going to be written into disk, we pulled the plug, right? And it was all lost. But no one knew it was lost because my balance was there and all the other requirements were there. So as far as the bank was concerned, as it went through the process, it was able to complete the transaction, but then it never got written to disk. So you pulled the power and now it's gone because it was in memory and it never made it to disk, right? So basically this transaction can't be marked as completed until those records are permanently stored, meaning if you pulled the power, well, it sucks, but when I plug it back in and the damn thing boots up again, I'm going to know that that transaction was there because it was successfully written. And that's what durability is. So if we look at a bank transaction and we kind of talked through these steps before, we can see how they're important. And I'm not going to kind of rehash this because I think I did a good job of that on the previous slide. But you can look at these steps and you can see, consistency is important because I have to make sure that I have money to check for sufficient funds, right? And durability is important because none of this is relevant if I don't write it to disk, right? So that's kind of all the steps there. And that's everything that I wanted to touch on. I wanted to keep this week a little bit lighter because you obviously have your big project due. So good luck with your project. Please ask any questions on this content or the project itself in the forums. And I look forward to seeing you next week.